So this video is going to be pretty short. We're going to do a lot of work in class. I wanted to give you some time maybe to go back. If you feel a little lost and want to talk about in the very beginning of this video, go back to the first time I went through section 1.7 and that will make a little more sense. I'm going to kind of pick up assuming that you've watched that video. So this is going to be sections 1.7 through 1.9. Kind of skipping over 1.8 is what we'll be doing mostly in class for this. So we talked last time we hit 1.7 about conversion factors. So remember that two things are equal to each other. We can write them as an equality. So an equality would be what we're going to call a conversion factor. We can put that into two different possible fractions. Two things that are equal to each other can go on top of each other as a fraction. That can help us cancel out a unit we don't want. So for example, if we want to go from pints to liters, and this is a conversion factor that we have, we could get rid of pints by throwing this one in there. Because if I have pints on top, because I'm starting with pints and I want to get rid of them, I'll put pints on the bottom. That will cancel pints out. I'll show you what it looks like in a second. Then if I have another conversion factor, so that would get me to quarts. If I have another conversion factor that goes from quarts to liters, I can kind of string these together to get from pints to quarts to liters. What we want to do when you are doing two or more conversion factors is not to think about it in two separate steps, but to kind of string along your conversion factors in one long chain. That's going to help you stay more accurate. It is going to help you have less room for errors, and it is going to save you time. And so if you're like, hey, I'm doing it one step at a time and then getting my calculator out and then doing the next step and getting my calculator out, come and see me and let's work on trying to string it all the way together so that you're only getting your calculator out one time at the end. It leaves room for less error and you are going to take up less time. So let's look at how we would set this up. So if I have 1 pint and I want to convert it to liters, I know this comes from 1 quart is equal to 2 pints. This comes from 1.057 quarts is equal to 1 liter. These are one of the conversions that will be given to you. If you see these things in the homework, you can look it up. There's a whole table in the textbook, also in the slides that I went over in the video where we went through section 1.4 and 1.7. It has like a whole little table of different conversions. You just can have that out while you do your homework. But on a test or a quiz, if I'm asking you about pints and quarts and that kind of stuff, I'm not expecting you to memorize those conversions. I would give those numbers to you. I would give them to you as equalities, though. I wouldn't give them to you as fractions. You need to know if two things are equal to each other, we can put them into a fraction. Now, you could put the fraction with the quarts on top or the quarts on the bottom. So you kind of have to see what your question is in order to know what you're going to be multiplying and dividing. One common thing that students try to do, and it makes it harder for them, is they look at a question like this. Let's just say, you don't have this, but it's like, hey, turn pints into liters, and you have those two conversions in blue I have there. Students want to go, okay, so I'm going to multiply by 2, and I'm going to divide by 1.057. Like, you don't have to do that. You don't have to know what you're going to multiply and what you're going to divide before you sit down and do it. Just look at what you have. So if I start with pints, and remember, this is all kind of one long fraction. If I start with pints, I need pints to go on the bottom of the next fraction. So in the bottom of the next fraction, pints are going to just go on the bottom. And then whatever it's equal to is just going to go on top. There's a website, a practice website, that I will post in D2L for you and that we can pull up in class that will help you learn how to drag and drop your conversion factors into the fractions in the right order. Again, left and right order doesn't really matter. It's just top or bottom what things need to go in there. So if I put those pints on the bottom, I'm going to cancel pints out. If I stopped there, well, you didn't do this part, I would have quarts. I don't want to stop there yet, though, because the question's asking me for liters. So we're going to go one step more. So we've canceled out our pints. We have quarts now. So in order to cancel quarts out, I got to put quarts in the bottom. So I look at my conversion factor. Oh, that number goes with quarts. So that's going to go on the bottom. whatever it's equal to goes on top. That's the rule. Whatever it's equal to goes on the other side of the fraction. That will cancel my quarts out, and that leaves me with liters, which is what it's asking me for. And so I will multiply the numbers on the top, divide all the numbers in the bottom. This is not 2 times 1.057. This is written as 1 divided by 2 divided by 1.057 in your calculator. So think about it in sections. The first number, multiply the top, divide the bottom. Multiply the top, divide the bottom. If you try to multiply across the whole top, then multiply across the whole bottom and write your numbers out and then divide them, it's going to take you 1,000 years to do a problem, and you've got to be fast with solving these problems on your exams. So just take it section by section, and that way you don't have to worry about writing a whole bunch of stuff down and maybe writing something down wrong. Start with your number, times whatever's on the top, divided by whatever's in the bottom. Times whatever's on top, divided by whatever's in the bottom. Continuing for as many fractions as you have, and then you hit equals when you're done. If you need help with this, call me over, or call, if we have an LA in class, call them over, and we can definitely work out how you to put these in your calculator so that you're efficient with your work. And now we've added on significant figures. So you want to not only think about what is your answer, but how many significant figures do you need your answer to be? If we're doing multiplication and division, we're looking for lowest number of significant figures. Our starting amount is 2 significant figures. That 0 counts because it comes in a number with a decimal and after a non-zero number. This is an exact. Anytime you are in the same system, like within the metric system or within the English system, like pints and quarts are both English, it's exact. This is actually a measure because it's between English and metric. The only one between English and metric that's not measured that is exact that you're going to have to memorize is the 2.54 centimeters equals 1 inch. That's exact. But any other, you would kind of consider that as measured. I will just say it's 9 times out of 10, the number of significant figures you start with is probably the number you're going to end with. If you're like, hey, I just can't handle doing all the sig fig stuff, usually it's the same 90% of the time. Sometimes it's not, but you know, if you're not sure, you can probably guess on that, okay? Significant figures is going to be a much bigger indicator of like whether or not you get a question right in lab than it will be in lecture. There will be a couple questions in lecture, definitely in the homeworks where it will matter, but as far as like testing over it, I think I have like 1 question in exam 1, and then everything else is, you really don't have to worry about it too much. So don't let that, be the straw that breaks the camel's back for you. Okay. So if you feel like you're a little confused with that, I want you to just go back up here. How many liters are in 1 pint? Here are your conversion factors, and see if you can put it together, and then come back to that slide and work it out. You also have a ton of homework you can use for practice, and we're going to be doing lots and lots of practice with this in class. One last little thing for today's slides. We're going to talk about temperature differences. So temperature is a measure of how hot or cold an object is related to how fast the particles are moving. We've already talked about that a little bit with our states of matter talk. You've got 3 different temperature scales. We use Fahrenheit, Celsius, and Kelvin. Fahrenheit and Celsius have degrees, and Kelvin is just K. Celsius to Fahrenheit, Fahrenheit to Celsius, those are some equations you can use, and then Celsius to Kelvin, those are equations you can use. You have a handout that is periodic table and equation sheet. It's a formula sheet. You'll have always on every test and every quiz, so you don't have to memorize anything that's on that sheet. So look at it, make sure you're using it. These numbers, just to make very clear, these numbers you're going to treat as exact for sig figs purposes. So for sig fig purposes, you would consider them infinite sig figs. So when you're thinking about, doing your math here with these, you want to treat those numbers as exact, which is infinite sig figs. This is going to require some algebra for you to rearrange. I think on the formula sheet, I don't think you're given both Celsius to Fahrenheit and Fahrenheit to Celsius. You're only given one of those. I have to double check on that. But you may have to do some rearranging in the question to figure that out. So brush up on algebra. Make sure you can rearrange it for C, for temperature in Celsius. Make sure you can rearrange it for temperature in Celsius for both of these. And make sure you know the order of operations, because your significant figures changes anytime you go between addition, subtraction, and multiplication, division. You will have to track your significant figures through that step. You can't just plug this in the calculator, get an answer, look at your least number of sig figs, because you have that pesky addition sign there that does not care the number of sig figs, it cares the decimal places. So be careful when you're doing homework questions with this to get the right number of sig figs for that. Here's a little scale just kind of showing you absolute zero is negative 460 Fahrenheit. If you're more familiar with Fahrenheit, that's how cold that is. Space is a little bit above that, like 2 or 3 Kelvin. Freezing point of water in all 3 scales. Celsius, you can clearly see, is based on water, right? 0 to 100 for water. So actually in Celsius is what we're going to use in the lab. Celsius is what most scientists use. Kelvin is what we use for a lot of our math, because it's an absolute scale. You don't have negative numbers. And so if we need to do math with temperature, but you don't really want to have a negative pressure or negative volume in your math, you use Kelvin because it doesn't have negative numbers. Celsius has lots of negative numbers. So does Fahrenheit. And then Fahrenheit is based off of, I don't know, this guy Fahrenheit was just like, I want to have this number. I think it's probably based on like body temperature being close to 100. But I think Celsius is more of what people are going to use around the world. Most countries use Celsius in general to describe the environment, and is based off of waters freezing and boiling. Okay, that's it. We'll practice with this in class. I'll see you then.